Good day, welcome to our school, the Math Hub Mathematics in Statuna Sandy. In today's lesson, teacher introduces a new topic, polynomials. We want to learn about polynomials. So we start off by defining polynomials. Polynomials deal with problems concerning algebraic functions with much emphasis on the order of powers. So the first note we write panaba is this: polynomials are algebraic expressions saka togona kuti polynomials are algebraic expressions kana kuti polynomials are families of algebraic expressions zvine the same effect, but chakanyanyokosha panapa after tastressa kuti these are algebraic expressions, we can call them functions with emphasis on order of powers. So that is what we are dealing with. Polynomials are algebraic expressions kana kuti functions with emphasis on the order of powers. So if you want to remember zvatakadzidza concerning the order of powers, munodzokera ku topic quadratics. But I define a quadratic function. Takati it is a function of the highest order, power 2. Tichiti the variable cannot unknown yatinge tiinayo inside the quadratic function inofanirwa kuva of the highest power 2 kana kuti inofanirwa kuva at most squared. So kana takutarisa polynomials, takuchitarisa linear functions, cubic functions, quartile functions, and so forth. This topic analyzes the relationship between factors and multiples. Let us write this down. Saka this topic, it analyzes the relationship between factors and multiples. Saka mufanirwa kuva a working knowledge of what a factor is. Define a factor as a term or a number, usually a number, which divides into another number without leaving a remainder. Factor a number inopinda mune number isingasiye remainder. Example, 2 effector ya 4 kana kuti 2 effector ya 6, because 2 anopinda muna 4 asingasiye remainder, 2 anopinda muna 6 zvakare asingasiye remainder. Whereas a multiple, we associate multiples with the times table, because multiples of 7 would be 7, 14, 21, 28, 35, and so forth. Multiples of 5 would be 5, 10, 15, 20. Saka we are taking 5, then multiplying it in succession with 1, 2, 3, 4, and so forth. That is counting numbers. Saka zvindikuzvitaura in passing uye rashidly, because it's assumed knowledge. You should know what an order is. Order zvinongoreva kuti power. Secondly, you should know what a factor is. You should know what a multiple is. But if you have problems with any of these terms, you can communicate via comments and we pause to explain them a little further. That is through another video, of course. But in this topic, polynomials, tichatarisa ukama, relationship between factors and multiples. Saka, on one hand, a factor is a lower order expression that gets into a higher order expression. So this is going to serve as a definition of a factor. Kana tichiti factor kuno ukachai-define madefinero ataita ku O level, but a number which divides into another number without leaving a remainder. Kuno more technically tinoti a factor is a lower order expression What does this lower order expression do? That gets into a higher order expression with remainder 0 kana kuti without leaving a remainder. So let us say without leaving a remainder. Main takeaway panapa madzangu ndekuti kunoku ku advanced level pyramids ma-factors edu ava ma-algebraic expressions. To define a polynomial as an algebraic expression, but in most cases it's presented as a function with emphasis on the order of powers. Tikati order zvinongoreva kuti power, and kana kuti kana mukada unyanya kuva technical exponent, but let us not use that term. Saka kana tiri ku O level and below, ma-factors edu manumber. Factors of 12 and 2, 4, 6, 12. Factors of 30 and 1, 2, 3, 5, 6, 10, 15, 30. Saka ma-factors edu ku O level and below ma-numbers. Kana taku A level ma-factors edu, especially under the topic polynomials, anenge ari my expressions. And bear with me, you are going to see what I mean in a moment. So that's how we define a factor. Kana tichi define a multiple manje. In like manner, my multiples edu anenge ari my expressions, not necessarily my numbers. So for defining a multiple, we are going to define a multiple as a polynomial that accommodates lower order expressions. So this is a polynomial that accommodates lower order expressions. Zichatanga ku make sense kana taku illustrator, so bear with me. Poly zvinorevei? Poly zvinoreva kuwanda, many. Then the part here, nomials, yakutudza kuti these are algebraic expressions. Saka ma polynomials ma algebraic expressions ane ma orders akasiyana. Kana tichiti order, tikutarisa pama unknown ari mukati me an algebraic expression, tiri kutarisa the highest power irimo. Kana highest power ari 1, tine inonzi a linear polynomial. Kana highest power ari 2, tine a quadratic polynomial. Kana highest power ari 3, tine a cubic polynomial. Then lastly, kana highest power ari 4, tine a quartile polynomial. Kana ari 5, we have different polynomials and so forth. Saka manotes atanyoraya, let us give material to them. What are we going to do? Let us dwell on an example. Saka example yatinoda kuita panapa ndeyekuti we have this polynomial. So this is our example. Example yetiri kuti we have a polynomial, the function of x, which is, so let us say we have the polynomial f of x such that f of x is equal to 2x squared plus 3x plus 1. Chatinoda kutanga kuita panapa. Takatarisa that polynomial, takatarisa that function. Tinoziva say the group it belongs to, kana kuti the family it belongs to, kana kuti what type of polynomial is it. So tinotarisa the highest power pama unknown edu, in this case the x, turn out into 2. Kureva kuti this is going to be a quadratic, talking about quadratic function, as atirambidzwi tikada kuti quadratic polynomial. Andika. Saka zvakakosha kuti whenever you are dealing with polynomials, you know which family they belong to. You know the type of that polynomial. So now, having what we have, we want to know what are the factors of that quadratic polynomial, cannot quadratic function. So we are having this function, the function of x being equal to 2x squared plus 3x plus 1. Let us assume that we can use factorization as a method of simplifying that quadratic expression. So using factorization, the first step, kuona kuti yakanyorwa in the form ax squared plus bx plus c. In layman terms, the first step, kuona kuti manyorerwo akaitwa quadratic function yedu, tiri kutanga na x squared, tozoenda pana x, topesera nenhamba yakangomira yega. Taona kudaro, then we are going to multiply the first and last terms. 2x squared times 1 the 2x squared. Tichada kutsvaga mafactors at 2x squared. Atinowana mafactors at 2x squared akamira sei? Ekuti tikama multiply anotipa 2x squared, asi tika add anotipa 3x. Saka panapa it's easy, ndi 2x plus x. 2x plus x ndi 3x, 2x times x ndi 2x squared. Kureva kuti taku replace the middle term na 2x plus x. Takuchi grouper. In our first bracket, tino factor out 2x kuti tisare tina x plus 1. From our second bracket, to factor out 1 to sare tina x plus 1. Got out eventually this is going to be equal to 2x plus 1, x plus 1, like this. Now, kumetsi mufunga kudzidzira ku identify ma patterns and relationships. Saka zvandoda kuti muone panapa ndeizvi. Kana makatarisa the lessons I did with my O-level students on factors, I showed them something. Ndakavaratidza nzira yekuita proof kana kuprova kuti mafactors avanyora for a certain number ndiwo ese here. Saka ndakati tinoita sei? Tikatora factors of 30 for example. This is equal to 1 is the inverse factor, tina 2, tina 3, tina 5, tina 6, tina 10, 15 na 30. These are the factors of 30. If we multiply the first and the last term, tinofanirwa kuwana 30. Tika multiply term inotevera ne term inotevera, tichibva kokutanga tichibva futi kokupedzisira, that will be 2 times 15. Tofunga wana 30. Tikazoti 3 times 10, towana futi 30. Tikazopedzisira nekuti 5 times 6, tichawana futi 30. So this is how we prove kuti ma factors are 30 tanyora ndiwo ese here. Denotanga tasirira a number. Imagine a case yekuti tasirira for example 5 uno. Tanyora tichiti 1, 2, 3, 6, 10, 15, 30. Patinozosvika pekuti tichati 1 times 30 yobuda, 2 times 15 yobuda, 3 times 10 yobuda, but 6 hatichisina to multiply nani. Saka iyi ndonzira yatinoshandisa kudi kuprova kuti tanyora zvakanaka. But chandinoda kukuratidza apa ndechekuti kana tichitine ma-factors number andika tikamultiplya ma-factors acho and tichifollowa a certain rule like mafollowero ataita apa tinofanirwa kuwana the original number. The takeaway from this explanation is if we have factors of even an algebraic expression and kana tikasatisfy a certain rule tikamultiply those factors, they should give us the original function. For example, kana mukatomultiply bracket ra2x plus 1 nebracket rax plus 1 munowana 2x squared plus 3x plus 1. Kureva kuti mabrackets awo, they are actually factors of that quadratic expression. So conclusion yatiri kuita panapa ndeyekuti therefore, let me write it in white because it's a note. 2x plus 1 and x plus 1 are factors of 2x squared plus 3x plus 1. Those are factors. The bracket ra x plus 1 ne bracket ra 2x plus 1, these are factors of the function of x, which is 2x squared plus 3x plus 1. Nemhaka yekuti these brackets, these expressions, divide into the original function without leaving a remainder. It's going to make sense when we do long division, which is going to be the subject of our next lesson. Saka tiri pano, there's something important we have to look at. Much of the work in polynomials is centered on the analysis and application of what is called the remainder and factor theorems. So I want to write this down as a note. Kuti in polynomials, we use what are called, these techniques are very important. Tine inons a remainder theorem, tozeta inons a factor theorem. So we have a remainder theorem and we also have a factor theorem. The factor theorem states that when a polynomial is divided by a factor, the remainder is 0. Saka nachiti factor theorem irungotaura zvandanganjitsanangura pandabva kutaura apa ndichiti when a polynomial is divided by a factor, the remainder is 0. Andika, because a factor kuroti kapinda mukati me polynomial inofanirwa kubuditsa remainder ya 0. What about remainder theorem? Kana takuita my examples, it's going to make apparent sense. Remainder theorem. Remainder theorem inoti when a polynomial is divided by a lower order expression, it leaves a remainder. So abatukuti when a polynomial is divided by a lower order expression, and I'm going to underline pakanzi lower order expression pakati koshera pababa, it leaves a remainder. It leaves a remainder. Saka factor theorem ringotiudza kuti tikaisa factor mukati mepolynomial tofanirwa kuwana remainder 0. Remainder theorem iri kuti tikatora polynomial tikaidivide with a lower order expression. I want to explain pakanzi lower order expression. Kureva kuti the highest power in the polynomial original function inofanirwa kuva hombe pane the highest power inenge iri mudivisor. And I know kuti it might not make sense tikasaisa example. So example panapa ndeyekuti let us say we can divide x cubed plus 3. Tinogona kuidivide tikaidivide na x minus 2. Whatever answer yatinowana inofanirwa kuva ne a remainder something. Ndozvirongotsanangurwa. Saka tikaisa a function, an expression in a lower order into an original function, we should get a remainder. Kana expression yatadivide mukati mepolynomial iri factor, remainder yedu ndi 0. Kana isiri factor, remainder yedu inenge iri something else. Ndozviri kutaurwa the factor theorem and the remainder theorem. Let us try to work on some examples, but we are now operating under a new subheading. Saka our subtopic I take focus on now is factors versus roots. This is what we want to focus on. So when we look at roots, my roots, these are solutions to solving polynomials. Patakasangana nema roots kazhinji kuma quadratic expressions. Ma answer tinowana tikasolve a quadratic equation to anonzi ma roots. And since takabva kuita quadratics, I think this is still apparent in your minds. A factor is an expression whereas a root is a solution. Saka a factor is an expression and ingetory expression, a lower order expression, a root is a solution. Cannot answer mugada kutora nenzira iyoyo. It's a solution, or in layman terms trukuti, it is the answer we get after solving. For example, and let us put an example pano. If x plus 1 is an expression, is a factor, and x plus 1 a factor, then x and equal to minus 1 is a root. Tsokera ikwataka itama quadratic equations. Mukasvika pa situation yekuti mune bracket ra x plus 1 nerimwe bracket. Kuti muwane ma answer enyu kana kuti muwane ma roots, anti ma equate that bracket to 0. Might x plus 1 is equals to 0, therefore x is equal to minus 1. Saka minus 1 is the root. Are you getting it? Saka pese patine a factor, tine an associate root. And kukosha kwazo mchakuona. So this implies a factor can be transformed into a root or a converse or vice versa. Saka tinogona kutanga tine a root, we can imply a factor from that. Togona kutanga tine a factor, toshanisa that factor to imply a root. Mapaona. So let us look at something like this. Saka panapa tikati if anga bracket ra x plus 1 multiplying 3x minus 2 is equal to 0. We have factors, two factors multiplying. Zoreva izvo kuti maroots edu akamira sei. Sateta ku equate every bracket to 0. So either x plus 1 is equals to 0 or 3x minus 2 is equals to 0. kureva kuti x iri equal to minus 1 which is a root, or x up inenge iri equal to 2 over 3 which is also a root. Saka zviri kutsanangurwa pano vadikani ndezvekuti bracket iri pamwe chete nebracket rinoi machi mafactors asi minus 1 na 2 over 3 maroots. Ndo zvatirongozama kutsanangura panapa. So as such, bracket ra x plus 1 and bracket ra 3x minus 2, they are factors, and x being equal to minus 1 and x being equal to 2 over 3, these are corresponding, cannot associative roots. Using linear factors, p of roots is equals to 0 and p of a non-root is equals to a remainder. We are going to look at that. In short, if a root and a non-root are substituted in place of a variable in a polynomial, the result is 0 and a remainder respectively. Let us give an example. Given that we have a factor x plus 1, and turns out it's a factor of a polynomial of x, where the polynomial is x to the 4 minus 2x squared minus 3x minus 2. This is what we are going to get. Okay. Tanda kuti munyore izvi pasi as some form of reminder. Ndiri kuda kuti munyore kuti p of roots is equal to 0. Monyora zvakare kuti p of non-roots is equal to a remainder. Saka izvi zvakakosha, toda kuzvitsanangura izvezvi, chingozvinyorai tozozvitsanangura mazvinyora. Saka we are bracketing it because of the importance it has. Okay. So what's happening? Let us say we have this polynomial. Taudzwa kuti p of x ndo polynomial yatinayo is equal to x to the power 4 and minus 2x squared minus 3x minus 2 and bracket ra x plus 1 is a factor. And okay. Saka tinotanga tada kuziva what is the corresponding root panapa. Saka kana x plus 1 ari factor, zvinoreva kuti x is equal to minus 1 is the root. Tawana sei root, tangotora bracket iri tikati riri equal to 0. Andika? So zvatakuita panapa, tofanga kuziva kuti p of root is equal to 0. Kureva kuti tika replace x uyu na minus 1, tikati p of minus 1 tinofanirwa kuwana 0. But kuti p of minus 1, zvoreva kuti since x tam replace na minus 1, pese pana x inside our polynomial, tofanga kupa replace na minus 1. Sapa inova chi minus 1 to the power 4 minus 2 multiplying chi minus 1 squared minus 3 multiplying minus 1 minus 2. Tikasolva izvo funga kuti pa 0. Ndo proof yekuti x is equals to minus 1 is a root. Root inobvepi? Root inobva pa factor. Saka patiri kuti non-root apa, tiri kuti tinenge tiine an expression isiri a factor, ndo inotipa a non-root. Asi kana iri a factor, inotipa a root. Let us solve it. Minus 1 to the power 4 ndi 1, because this is an even power. Minus 1 squared ndi 1. 1 times minus 2 ndi minus 2. Minus 3 times minus 1, that's plus 3. And then apa tina minus 2. Then panapa tikati 1 minus 2 ndi minus 1. Totichi plus, what about 3 minus 2 ndi 1? So minus 1 plus 1 is equal to chi? To 0. Tosvatanga tichitsanangura. Tika x tikamu replace ne root. Root rinenge rabva pa factor. Tinofanirwa kuwana 0. This is, if not the most important skill set yamunoda kana muchidhila namapolynomials. This is the most important skill set. So kuti pese pamuchita mapolynomials, this is going to be handy. Okay, what about we deal with a non-factor? And kati dilene non-factor. Kachiti non-factor kana kuti non-root rather. Tiri kuti I root raturikuwana I number yaturikuwana from a non-factor. So for example, tiri kuti if the same polynomial and p of x is equals to x to the 4 minus 2x squared minus 3 minus 3x minus 2 is divided by a non-factor. What is the non-factor? The non-factor is x plus 2. What it means, is it's divided by a non-factor. Sakatikati p of a non-root, it gives us a remainder. Saka p of non-root apengerichi. Can you see within the minus 2? Because we still have to equate this to 0. We must equate bracket ra x plus 2 to 0. Kuti tuone kuti our non-root panapa ndi minus 2. Saka this is going to be equal to, pese pana x takureplace na minus 2. Saka ichava minus 2 to the power 4 minus 2 multiplying minus 2 squared minus 3 multiplying minus 2 minus 2. This is equal to, then minus 2 times minus 2 times minus 2 times minus 2. It's a positive answer because of an even power. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Then minus 2 squared in the 4, 4 times minus 2, that's minus 8. Minus 3 times minus 2, that's plus 6 minus 2. And if we are to solve this, tinoona kuti panapa answer ndiani ndi 12. Saka 12 yatawana iyi is a remainder. 12 is the remainder. So let us write this conclusion. Therefore, 12 is the remainder if p of x is divided by x bracket x plus 2, like this. Upon this is very important. This is very important. Not this. Note this, the strategy outlined immediately above only works when using linear factors. Saka izvo zvinongoshanda kana mafactors edu factor riri linear. Linear factors zvinoreva kuti anoni edu kana kuti variable iri to the power 1. That's what it means. So let us say this, the aforementioned only works for linear factors. Zvakakosha kuva nazvo manotsi enyu as a consistent reminder. When using quadratic and other higher order factors, the only workable way out of it is to make use of long division. Since long division is ideal for all types of factors, linear, quadratic, cubic, quartile, and so on, it is mainly reserved for non-linear factors because the method outlined above provides a less laborious way to account for linear factors. Okay, saka in our next lesson, tichakudzidzisai long division. It's going to be fascinating. This makes the natural end of our lesson. If it so happens that you wish to join our school, you have to WhatsApp us on that number. Our school is the Methab mathematics in Statu na Sandy. To join our school, WhatsApp us on +26371521331, which can simply be to Zimbabweans 0715213310. Kana mine ma questions amuda kufunza, you can utilize the comments section or use that WhatsApp number to get to us. Otherwise, thank you for your attendance. I hope you learned something. Keep on learning, be more patient, keep on working, and you are going to have a harvest. Take care.